Hello and welcome to Earthquake Tip number 23. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Subhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to comprehend language to our professionals who are in the field designing and constructing structures, especially our architects and engineers. But before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. This earthquake tip number 23 will explain you why are buildings with shear walls preferred in seismic regions. The importance of reinforced concrete walls, also known as shear walls, to improve earthquake resistance in RCC buildings came into existence after 2001 Bhuj earthquake. Let's understand what is shear wall building. Look at this figure. RCC buildings often have vertical plate-like RCC walls called shear walls in addition to slabs, beams, and columns. These walls generally start at the foundation level and are continuous throughout the building height as shown here. The thickness of these walls can be as low as 150 mm or as high as 400 mm in high-rise buildings. See the upper left-hand side of figure 1. The shear walls are usually provided along the length and width of the buildings. Shear walls are like vertically oriented wide beams that carry earthquake loads downwards to the foundation. Why shear walls are advantageous? Let's understand that now. Properly designed and detailed buildings with shear walls have good performance during past earthquakes. The overwhelming success of buildings with shear walls in resisting strong earthquake is summarized by this quote: "We cannot afford to build concrete buildings meant to resist severe earthquakes without shear wall." I unquote. This is the quote given by Mark Fintel, a famous earthquake engineer from USA. Shear walls in high seismic zones requires spatial detailing. However, in the past earthquakes, even buildings with sufficient amount of walls that are not specifically detailed for seismic performance but had enough well-distributed reinforcement were saved from collapse. These shear wall buildings are quite popular choice in many earthquake-prone countries like Chile, New Zealand, USA. Shear walls are easy to construct since reinforcement detailing of these walls is relatively straightforward and therefore easily implemented at site. Further, shear walls are efficient both in terms of construction cost and effectiveness in minimizing earthquake damage in structural and non-structural elements. Now let's understand the architectural aspects of shear walls. Most RCC buildings with shear walls also have RCC columns. These columns primarily carry gravity loads, that is the vertical loads, whereas shear walls provide large strength and stiffness to the building in the direction of their orientation, which in turn significantly reduce lateral sway of buildings and thereby reduces damage to structure and its contents. Shear wall also carry large horizontal forces and therefore the overturning effects on them are also large. Thus, design of foundation of shear wall require special attention. Also, shear wall should be provided along preferably both length and width of the building. However, if they are provided only in one direction, a proper grid of beams and columns in the vertical plane must be provided along the other direction to resist strong earthquake effects. Further, door or window openings can be provided in shear walls, but their sizes must be small to ensure least interruption to forces to walls. Moreover, openings should be symmetrically located. Special design checks are also required to ensure that the net cross-sectional area of a wall at an opening is sufficient to carry the horizontal earthquake force. As you can see in this figure, shear walls in building must be symmetrically located in plan to reduce ill effects of twist in buildings. As you see here, these could be placed symmetrically along one or both directions in plan. Also remember, shear walls are more effective when located along exterior perimeter of the building. Now let's understand the ductile design of shear walls. Just like RCC beams and columns, RCC shear walls also perform much better if designed to be ductile. Overall geometry proportions of the wall, type and amount of reinforcement, and connection with remaining elements in the building help in improving the ductility of these shear walls. Ductile detailing code, that is IS 13920, provides special design guidelines for the same, and let's understand them now. As you can see in this figure 3, shear walls are oblong in cross section. That is, one dimension of the cross section is much larger than the other. While rectangular section is more common, L and U-shaped sections are also used. Thin-walled hollow RCC shafts around the elevator or lift core of building also act as shear walls. Now let's see the reinforcement and boundary element details for these shear walls through this figure 4. As you can see in the figure 4a, the steel reinforcing bars are to be provided in walls in regularly spaced vertical and horizontal grids. The vertical and horizontal reinforcement in the wall can be placed in one or two parallel layers called curtains. Horizontal reinforcement needs to be anchored at the end of the walls, whereas the vertical reinforcement should be distributed uniformly across the wall cross-section. The minimum area of reinforcing steel to be provided is 0.25% of cross-sectional area along each of horizontal and vertical directions. Now let's look at this figure 4b to understand the boundary elements. Under the large overturning effects caused by horizontal earthquake forces, edges of shear walls experience high compressive and tensile stresses. To ensure that shear walls behave in ductile manner, the concrete in the wall and regions must be reinforced in a spatial manner to sustain load reversals without losing strength, as shown in this figure 4b. And regions of the wall with increased confinement are called boundary elements. Remember the earlier tip, the spatial confining transverse reinforcement, that is closely spaced lateral ties in the columns of RCC frames. This spatial confining reinforcement in the boundary element is similar to that only. Also shown in figure 4b, sometimes the thickness of shear wall in these boundary elements is also increased. RCC shear walls with boundary elements have substantially high flexure or bending strength or horizontal shear force carrying capacity and are therefore less vulnerable to earthquake damage than walls without boundary elements. This is all about earthquake tip number 23. You can download this tip from www.bmtpc.org. The next earthquake tip, that is earthquake tip number 24, will be on how to reduce earthquake effects on buildings. Thank you.